Okay, we're going to have a go at a Decision 2 critical path analysis exam question. Typical question. The first thing we've been asked to do here is complete the activity network for the project. So you can see up here we've got 5 of the 9 activities already with boxes, so we need to fill in the remaining 4 activities and then mark the precedence, which is given here in this column, by using the arrows. So that's for the first 3 marks. So A, as you can see, no predecessors. B and C both require A as a predecessor. D requires both B and C. So we can complete arrows like so. E just requires C. We now need to draw a box for F, which has D as a predecessor, so be sensible to draw it up here. So, arrow here, and F takes 2 days, so 2 in that middle part of the bottom boxes. If we then draw G on, well, G is preceded by D and E, and actually looking down so is H, so we put those both there, G, H. Both preceded by D and E. So we can't really avoid these 2 lines crossing. We would normally try and avoid that if possible. G takes 4 days, H takes 6 days. And then we have finally activity I, which is preceded by F, G and H. So lines with arrows from F, G and H, and I takes 2 days. Now, as F, G and H all go to I, this is where the whole of the activity will finish. So we don't require any more activities written on here. Okay, so that's the first 3 marks in the bag. Part B, find the earliest start time for each activity. So this is the easier bit, the forward pass. A has no predecessors, so we can start that at time 0. B requires A to be completed before it can start, so the earliest that can be is after 2 days. C also requires A, so again the earliest that could be is after 2 days. D requires both B and C to be completed. Well, the minimum that B is going to be completed after is 6 days, the 2 days for A and the 4 days for B. And the minimum for C is 8 days, 2 from A and then 6 from C. So clearly D can't start until both of these are finished, so we go with the bigger one, we go with the 8. E only requires C, so that has to wait for C to finish. Next, if we go up to F, that just requires D, so that's 16. G requires D, which we've just discovered is 16, and E, well, that could potentially be 11. So again we go with the bigger. Now to H. H is D and E, so again 16. And then finally to H, well, 18 here, 20 here, 22 here. Which means 22 plus 2 that we're going to require 24 days to complete every activity. Okay, so part C now. We've already bagged 5 marks. For part C, latest finish time for each activity. We put I in. The criteria for this is that the project isn't delayed. So we want the latest finish time that doesn't delay the whole project. So G has to finish at 22 to avoid I being delayed. F has to be finished at 22 to avoid I being delayed. And H has to finish at 22 as well. They all feed into I. So if any of these 3 activities finished later than 22, it would delay I. D. Well, D needs to be completed by 20 for F, because 20 plus 2 would enable F to finish at 22. But it also needs to finish in time for G to finish in 22. Well, that means that it would need to actually finish at 18, because 18 and 4 is 22. And then going down to H, it would actually need to finish at 16, because 16 and 6 is 22. We go with the smallest of those because we can't delay the project. If it finished any later than 16, then that would delay H, because we'd still have to add 6 days. That would make this bigger than 22, thus delaying the project. So 16 goes in there. For E, well, E precedes G and H. For G, E would only need to finish at 18, because 18 and 4 is 22. But for H, it would need to finish at 16, because 16 and 6 is 22. And again, we go with the smallest, so we put 16 in there. For B, well, B only precedes D. D needs to start at 8, because it needs to finish at 16. So B could finish at 8. C precedes D and E, so here 8. For E, wouldn't actually need to finish till 13, because 13 and 3 gives us 16 there, but because it feeds into D, we will need to put an 8 there. And for A, well, here we could get away with starting at 4 for B, but we need to start at 2 for C, so we put the 2 in there. So we've now got these first 7 marks. Next bit says find the critical path. Well, the critical path is the path with all the critical activities. Critical activities being activities where the difference between the earliest start time and the latest finish time is the same as the time the activity takes, the duration. So A is clearly critical. B isn't, because we've got 6 there and 4 there. C is. E isn't. D is. F isn't. G isn't, because 22 minus 16 isn't 4. H is, and obviously I will always be, the last activity will always be if everything else terminates there. So we have a critical path of A, C, D, H and I, and the time for completion is 24 days. The next part of the question asks to state the float time for each non-critical activity. Well, I've written up the non-critical activities here. They're the ones that aren't part of the critical path in this example. B, E, F and G. We have a float time of 2 days for B. That's because if we look here, 8 minus 2 gives us 6. The time it takes is 4, therefore there's 2 days spare or float. We now look at E. 16 minus 8 is 8 days. Takes 3, so difference of 5. For F, 22 minus 16 gives us 6. Takes 2, difference of 4. So it's a spare time, the float time. The final one there is G. 22 minus 16 gives you 6. We've got 4, so we've got a float of 2. Says, given that each activity starts as early as possible, draw a resource histogram for the project on figure 2. So if we move to figure 2, so on figure 2 we have the time in days on the horizontal axis and the number of workers on the vertical axis. The number of workers is given in the table, the workers required here for each activity. So time 0 to time 2, so the first 2 days, the only activity taking place is activity A, which requires 3 workers. So we can put 3 workers in there, and that's activity A. From day 2, starting at the earliest times, we have B and C. Well, I'm going to put the critical path along here, I think, along the bottom. So our critical path is C, which is from day 2 to day 8, and C requires 1 worker. Next is D, which goes from day 8 to day 16 and requires 3 workers. Next is H. H goes from day 16 to day 22 and requires 1 worker. And then finally I requires 3 workers from day 22 to 24. Okay, so there's the critical path. Activity B starts at 2, but it's going to finish, because it only takes 4, so it's going to finish at 6. B requires 2 workers, so that's going to look like that. E starts at 8 but will finish by 11 because it only takes 3 days. So E, again 2 workers, and finishes at 11. F will start at 16, requires 2 workers, but only takes 2 days. G will start at 16, takes 4 days, and requires 2 workers as well. We're going to put G at the bottom, so 4 days, and F above it, 2 workers for 2 days. The reason I've done that is to avoid having any gaps underneath. It's a histogram, so it shouldn't have holes underneath. If I put G above F, that would have been wrong. And there's your resource histogram done. So that's another 4 marks. The final part of the question says there's only 3 workers available at any time. Use resource levelling to explain why the project will overrun and state the minimum extra time required. Well, what options have we got here? We've got 3 workers, so the problems really lie here at these days where we have too many workers. F here has to wait for D to finish, so it can't start any earlier. It's the earliest start time, but could it start later? Well, F needs to finish by 22, and it only takes 2, so F could slot in here. So it is possible for F to slot in here. It takes 2 days, needs to be completed before I. E though, well, E could start as late as 13, but that's not really going to help anything, is it? If E started later, it's not going to enable anything else. So the problem really is the 3 days that E takes. So the explanation here is that E can't be moved to help. Project delayed by duration of E, which is 3 days. So that's basically all you can really say on that. You can see there's nothing we can do with E. If we push E, whatever we do with E, it could happen after D, but it would mean that other things that require D to be finished, like G and H, wouldn't be able to start. So it's going to delay. H is part of the critical path. It's going to delay the project by 3 days.